All right, so at this point, we're trying to find out what we can add and subtract together to get 7 pi's over 12. So 7 pi's over 12 is going to be just a little bit bigger than 6 pi's over 12, which is pi over 2. So it's going to be somewhere up in here. Okay, so we know we're in quadrant 2. And I keep calling your attention to that because it's going to be handy in the next time. So this kind of looks like an 11. It's 7 pi over 12. So what I'm going to try first is adding a pi over 3 to a pi over 4. So if I get a common denominator of 12, I'm going to multiply these by 4, multiply these by 3. So my denominator is 12. 4 pi's plus 3 pi's is 7 pi's. So I know that this is my alpha and this is my beta. And the order doesn't matter when you're adding, because 2 plus 3 is the same thing as 3 plus 2. Okay, so pi over 3 is the same thing. When I add it to pi over 3 plus pi over 4 is the same thing as pi over 4 plus pi over 3. So I'm going to make this my alpha and this my beta. So going in, I've got the cosine of pi over 3 plus pi over 4, so there's my alpha, and there's my beta. And so using our trigonometric identities, which I've conveniently lost, for cosines, we've got cosines and cosines. So this is going to equal cosine alpha, cosine beta, and instead of plus, it's going to be minus sine alpha, sine beta. So I just need to substitute in my angle measures. So now I've got cosine of pi over 3 plus, not plus, cosine of pi over 4 minus the sine of alpha, which is pi over 3, and the sine of beta, which is pi over 4. And I know all these ratios. So the cosine of pi over 3 is 1/2. Cosine of pi over 4 is root 2 over 2, minus the sine of pi over 3 is root 2 over 2 times the sine of pi over 4, which is root 2 over 2. So my denominator again is a 4, and I'll have a root 2 minus root 6. Root 2 minus 6 over 4. Okay, so we knew it was in quadrant 6. This is a smaller number minus a bigger number, so it's going to give us a negative ratio. All right, so what if we have the sine of 19 pi's over 12? Sine of 19 pi's over 12. So things that I know would reduce, would a 12 pi over 12, well, then I would have to add 7 pi's over 12. Okay, so I don't like that. But if I do 9, so let's just play with this just a little bit. First of all, what quadrant are we in? 19 pi's over 12. This is 6 pi's over 12. This is 12 pi's over 12. Okay, this is 18 pi's over 12, so I'm down in here. I'm in quadrant 4. So in quadrant 4, now we just got to figure out numbers that we can add or subtract together to get 19 pi's over 2. So let's just go with, well, if I do 15 pi's over 2, I'm thinking over 12. I keep saying over 2. It's over 12. That is going to reduce by 3's to 5 pi over 4. Okay, by 3's, that's going to reduce to 5 pi over 4. So I've got 15 pi's over 12. Well, now I need 4 pi's over 12. And if I do 4 pi's over 12, that reduces to a pi over 3. So I'm just kind of sort of messing around to see what I get. Okay, so 15 pi's over 12, reduce it by 3, and I get a 5 here and a 4 here. Meaning I need now 4 pi's over 12, because those added together is 19. And reduce that, you get pi over 3. So this is my alpha, and this is my beta. So my new formula is the sine of alpha times the cosine of beta. And then since I'm adding here, I should rewrite that. That becomes 5 pi over 4 plus pi over 3. So that's my alpha, that's my beta. Okay, and so then I have plus the cosine of alpha times the sine of beta. Can't see nothing. All right, so my sine of alpha is going to be 5 pi over 4. Cosine of beta is going to be cosine over pi over 3. That sounded like I said over pi over 3. The cosine of pi over 3, which I wrote as a 4, plus the cosine of alpha is 5 pi over 4, and then the sine of beta would be the sine of pi over 3. All right, so now we just slap in our ratios with the sine of 5 pi over 4. That's going to be a negative root 2 over 2. The cosine of pi over 3 is 1/2. Plus the cosine of 5 pi over 4 is a negative root 2 over 2. And the sine of pi over 3 is a root 3 over 2. So once again, we've got our denominators at 4. So I'll have a negative root 2. And then minus root 6. Which is almost what we, oh, it is what we got a while ago. It's not what we got a while ago. It's almost what we got a while ago. So this is a negative root 2 minus 6. This was a positive 2 minus 6 over 4. All right, so let's try a couple more exciting ones. We have the secant of negative 7 pi over 12. Okay, secant, and I actually could have used this on the last one. Okay, what was the last one? The last one was sine. No, we couldn't because it was positive. All right, never mind. Flip on back. All right, secant is the reciprocal of cosine. Cosine is even, which means it doesn't matter if this is positive or negative. Okay, does not matter if this is positive or negative. It will give me the same ratio. So I'm going to ignore that negative, and I'm going to say the secant of a positive 7 pi over 12 will give me the same ratio. And that's just going to make life easier. And we actually already figured this thing out. So remember, though, that this is 1 over cosine. So I have to remember this entire thing is in the denominator. And so I am going to make this 1 over the cosine of 7 pi over 12. And we looked a while ago, I can add up pi over 3 and pi over 4. And when I get common denominators of 4 and 3, those give me common denominators of 12. So I've got 4 pi's over 12 plus 3 pi's over 12 gives me my 7 pi's over 12. So when I fill this in, I've got cosine of alpha plus beta. So cosine of alpha plus beta is going to give me cosine alpha cosine beta. And instead of adding for cosine, we're going to change it to subtraction. And I get minus sine alpha sine beta. So remember, all of this is under a 1. So my next step is going to be, well, what's the cosine of alpha? My alpha, let's just rewrite it again so you can see what's happening. My alpha is going to be pi over 3, and my beta is pi over 4. So the cosine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. Very long denominator. All right, so what's the cosine of pi over 3? Cosine of pi over 3 is going to be 1/2. Cosine of pi over 4 is root 2 over 2 minus the sine of pi over 3 is 1/2. Or sorry, is root 3 over 2. And the sine of pi over 4 is root 2 over 2. So now I've got my denominators. So what do I have here? I've got 1 times root 2. So I've got 1 over root 2 over 4. So multiply those, minus root 6 over 4. So now what do? I'm going to put those under a common denominator. So I've got root 2 minus root 6. That was a long root. Hang on. 1 over root 2 minus root 6 over 4. So now I can flip and multiply. So that's going to be a 1 over a 1 times the reciprocal of this, which is going to be 4 over root 2 minus root 6. Okay, so this is my answer so far, but now I've got to rationalize. So rationalize with the conjugate. So my conjugate will be 4 over root 2 minus root 6 times the conjugate of root 2 plus root 6. So across the top, I'm going to get 4 times root 2 plus root 6. And across the bottom, I'm going to FOIL. So root 2 times itself is 2. This is going to be a positive root 12 and a negative root 12. And then I'll have a minus 6. So minus 6. So 2 minus 6 is negative 4. And I end up with root 2 plus root 6. So that reduces to a negative root 2 plus root 6, or negative root 2 minus 6. Okay, so it's the rationalization that kind of causes some issues here. And that, holy cow, I forgot this whole thing was under a 1. Okay, so, no I didn't. It's right there. Everything's fine. Okay, so now what we're going to do, that was the hard stuff. So now we're going to back up and we're going to make some easier ones. So I'm going to work backwards. I've got the sine of 5 degrees times the cosine of 25 degrees, which are both not benchmark angles, plus the cosine of 5 degrees times the sine of 25 degrees. So I want to see what I'm working backwards to. So I notice I've got sine alpha cosine beta plus. So sine alpha cosine beta plus, the plus is on top. So I'm going to work backwards and say this must be sine alpha plus beta. So this is my alpha, beta, alpha, beta. So what I have is the sine of alpha plus beta. So that gives me the sine of 5 plus 25, which happens to be the sine of 30. And I know what the sine of 30 is. It is 1/2. Okay, so what if I have cosine 30, cosine 15? And then I'm going to subtract sine 30, sine 15. So I know I've got cosine alpha, cosine beta, sine alpha, sine beta. So I'm looking for cosines followed by sines. So cosines followed by sines, but I notice I'm using a negative. The negative is on top. So work backwards, I need to do this as addition. So this will be the cosine of alpha plus beta, which will give me the cosine of 30 plus 15, which is the cosine of 45, which is root 2 over 2. Makes it so pretty. All right, so let's try another one. We have the tangent of 25 plus the tangent of 5 over 1 minus tangent 25 times the tangent of 5. So when I compare to what I've got a whole bunch of tangents sitting here. So comparing to my tangents, if my top value is addition, the top value is addition, so work backwards, I'm going to be adding alpha and beta. So this is going to be tangent alpha plus beta. So tangent alpha plus beta becomes tangent 25 plus 5, which gives me the tangent of 30, which gives me root 3 over 3. Okay, so they're just little shortcuts that we work through. Let me see if I just want to make this a little bit longer. Let me do 2 more. Actually, you can do those 2. Let me set up. Yeah, we're going to do another one. So let me make this one a little bit longer so that we can finish out this problem type. And then we'll finish out with a 3rd video, or 4th. I can't remember where we're at anymore. So I've got the sine of 5 pi over 12 times the cosine of 13 pi over 12 minus the cosine of 5 pi over 12 times the sine. Why do I always start writing in the middle of the page? 13 pi over 12. Okay, so this is sine alpha cosine beta, cosine alpha sine beta. So I'm looking for sines, cosines, and subtraction. So looking for sines, cosines, and subtraction, I must look at the bottom sign here, so it's the bottom sign there. So I'm doing sine alpha minus beta. So sine alpha minus beta. Well, what's my alpha? I get the sine of 5 pi's over 12 minus 13 pi's over 12. So 5 pi's over 12 minus 13 pi's over 12 is going to be negative 8 pi's over 12. Remember that sine is an odd function, so if I change the sign on the inside from a negative to a positive, I'll have to change this positive to a negative. So now I've got negative sine of positive 8 pi over 12, but that reduces by 4s. So I've got negative sine of 2 pi over 3. So what is the sine of 2 pi over 3? The sine of 2 pi over 3 is negative 1/2. So this negative is coming along for the ride, and then I get a negative 1/2, which means my answer is positive 1/2. And then we're going to do one more and then pick up another video. So I've got cosine of 7 pi over 12. And I've got cosine of pi over 3. And then I'm going to add the sine of 7 pi over 12 times the cosine, times the sine, that was lovely, of pi over 3. Okay, so I've got cosines plus sines. So looking at cosines plus sines, well, since it's addition, addition is on the bottom, so I'm going to pay attention to subtraction on the bottom. So this is actually cosine of alpha minus beta, which means I've got cosine of 7 pi over 12 minus pi over 3. I'm going to need a common denominator. And so this is going to be times 4 times 4. So now I've got the cosine of 7 pi's over 12 minus 4 pi's over 12 is 3 pi's over 12. And that reduces by 3's to pi over 4. So this is actually cosine of pi over 4, which is root 2 over 2. So I am going to pause this one, and I think we're going to get one more video out of this section. It's going to be a long one, but we'll get one more video out of this section, and then you'll be done with 8.5.